the subject you are scoring very good marks. Only science is the problem now. Okay, others also share your marks so that I can plan something for that. Okay, now maybe we need to change our strategy. Okay, for science. Okay, just a minute. Okay, then let us start with refraction. What is refraction of light?
The bending of light ray.
Yes, the bending of the light when it passes from one medium to another medium. Why does the bending happen? Okay, then what is the reason for the bending? So what happens over here? See, refraction. Refraction is nothing but the bending of the light when it travels from one medium to another medium. Suppose this is the interface of two media. Okay, interface of two media means what happens over here? See, then the two mediums are separating each other. Suppose the upper medium is rarer medium, the lower medium is denser medium. You know what it means by rarer medium and denser medium? Then, so rarer medium is the medium in which light travels comparatively faster. Denser medium is the medium in which light travels comparatively slower. Okay, so here what happens? Suppose this is our normal. Then if a ray of light comes from the rarer medium, strike the interface of the two media, then instead of going straight, okay, it bends the direction and goes in this direction. This mainly happens because of the change in the speed of light when the medium changes. Change in the speed of light when the medium will change. Okay, now here what happens? This angle is called as the angle of incidence and this angle is called as the angle of refraction. Here you can see that. See, this vertical line is the normal. Okay, the ray which was supposed to go over here is bending in this direction. So you can see that when the light goes from the rarer medium to denser medium, it bends towards the normal. It bends towards the normal. Okay, then next thing after this comes is this. When the ray of light will go from the denser medium to rarer medium, what will happen? Okay, it will be exactly opposite of this. Okay, see, if suppose this is the interface of the two media, this is the normal over here, then the upper medium is denser medium, this is rarer medium, so the ray of light will go strike the interface of two media and then instead of going straight, okay, it bends in this direction. Okay, now suppose this is the normal, you can see that the ray was going, instead of coming in this direction, the ray is going over here. You can see that the ray will go away from the normal. Okay, in this way the refraction of the light will take place. But here the refraction of light obeys two laws. The first law says that the incident ray, the refracted ray and the normal at the point of incidence to the interface of two media lies in the same plane. Lies in the same plane. Okay, then now the second law is that what happens over here? See, if suppose the ray of light is going from one medium to another medium, that time what happens? Then if you take the ratio of the two angles, the sine of two angles, that is the angle of incidence and the angle of refraction, then you will find that this sine I divided by sine R is constant. Is a constant for a given pair of media. Okay, constant for given pair of media. Given pair of media. Okay, and then what happens over here? See, then remember, it's not a universal constant, that is, which is same for all, but what happens? It will change with the pair of media. Okay, for example, glass to water, different, water to diamond, different, air to water, different, air to kerosene, different. So it will happen as the medium will change, the constant will also change, but still we call it as the constant because it is constant for the given pair of media. Okay, so, and here what happens, this statement which I have written on the board, that is sine I upon sine R is equal to a constant for the given pair of media, is called as Snell's law. Is called as Snell's law. Okay, and this law, okay, Snell's law, then this law fails in two conditions. Okay, which are the two conditions? The first condition is that when the light is incident normally. When light is incident normally. Okay, whenever the light will incident normally, then what will happen that time? Then the angle of incidence I is equal to angle of refraction R is equal to 0, and that is why what will happen? This sine I upon sine R, okay, will be equal to not defined. Okay, not defined. And in such condition, what will happen? The Snell's law will fail. In this condition, the Snell's law will fail. second condition when the Snell's law fails is that when the two mediums of the same refractive index, that is, a ray of light will strike the plate surface, but because of being the same refractive index, then what will happen? It won't change. It will continue to move in the same direction. Which what happens? The medium changes, but the light does not bend. The medium changes, but the light does not bend, and it continues to move in the same direction. And this is what will happen. Then this Snell's law will fail in the two conditions. So here what we got from the second law is that sin I upon sin r is equal to a constant for the given pair of media. Okay, and now see, this constant is very important for us. Then when we get this sin I upon sin r is equal to a constant, then this constant is represented by n to 1. N to 1. Okay, then and here you know what happens, this n to 1 is called as refractive index. Refractive index of second medium. Index of second medium with respect to first medium. Second medium with respect to first medium. With respect to first medium. Okay, refractive index of second medium with respect to first medium. Okay, then now here what happens, see, refractive index, you can assume that it is nothing but the bending capacity. More the refractive index, more bending will happen. Lesser the refractive index, less bending will happen. So that's what happens over here. Sin I upon sin r is equal to a constant. Okay, denoted by n to 1. Denoted by n to 1. Okay, now here what happens, see, this constant, that is sin I upon sin r is equal to constant, then the same constant, that is n to 1 is equals to sin I upon sin r. Okay, it can also be represented in terms of the speed of light in two media. It can be represented in terms of speed of light in two media. Suppose this is the interface of two media, then here the speed of light is v1, here the speed of light is v2. Okay, then now what will happen over here, see, as the light goes from one medium to another medium, the speed changes. So here what happens, suppose the ray is going this way, then and bending over here and going in this direction, angle of incidence, angle of refraction, then you will find that n to 1 is equal to sin I upon sin r, and it will be equal to how much? v1 upon v2. It is equals to v1 upon v2. Okay, that is the speed of light in first medium divided by the speed of light in second medium. Okay, again over here what happens, see, we know that last year we studied v is equal to nu lambda. Okay, so v1 will be equal to how much? v1 is equal to nu into lambda 1, and v2 is equal to how much? v2 is equal to nu into lambda 2. Nu into lambda 2. So you must remember one thing over here. What is that? That is, when the light goes from one medium to another medium, then out of the four parameters over here, 3 changes. Which are the four parameters? The four parameters are this here: direction, then speed of light, then wavelength, and frequency. So here what happens? See, direction changes because speed changes because wavelength changes, but the frequency remains same. The frequency does not change. So if you cancel these two frequencies, what you will get over here? v1 upon v2 is equal to lambda 1 upon lambda 2. Lambda 1 upon lambda 2. Okay, and one more thing over here. See, if suppose you observe that when you keep a pen half inside the water and half outside the water. Okay, suppose here is the water, the container. Then if you take one coin and keep it over here, then what will happen? The two rays of light coming from this point go from the coin, they go in this direction like this. Okay, and then what will happen? They will bend and go in this direction because they are going from the denser medium to rarer medium. So they will travel away from the normal. They will travel away from the normal. When you retrace them backward, they appear to meet at this point. They appear to meet at the point above the actual point, and because of this, what will happen? Then, okay, then because of this, the coin appears to be raised. The coin appears to be raised over here. Okay, and then now what happens over here? See, I made a very small diagram. I will make a bigger one. See, suppose this is your container. Then in the container, the water is up to this point. Here is the coin. Here is the point O on the coin. Then the two rays of light are going this way. One here, the second over here. Then next normal. Here is one normal. Then this ray of light will go in this direction. This ray of light will go in this direction. Then if you retrace them backward, they will appear to meet at this point. Okay. upon apparent depth. In this way, what happens? You get 4 formulas for the refractive index of a medium. Okay, here you got the 4 formulas for the refractive index of a medium. When the light, refractive index of one medium with respect to another medium, when the light travels from one medium to another medium. Okay, then after this, what happens over here? These are the 4 formulas. Then now, because of the natural tendency of the human beings to compare the quantities with the ideal quantities. In comparison, then we compare the refractive index of a medium with the refractive index of vacuum or the air. That refractive index is called as absolute refractive index. Absolute refractive index. So, what is absolute refractive index? Okay, then so if you define the absolute refractive index, it is defined as, then it is the refractive index. Refractive index of a medium. Refractive index of a medium with respect to vacuum. With respect to vacuum or air. Vacuum or air. So what happens over here? The refractive index of a medium is given by N medium is equal to C upon V medium. N medium is equal to C upon V medium. Okay. Then next, here what is C? C is the speed of light in vacuum. Speed of light in vacuum. Okay. And Vm is the speed of light in medium. Speed of light in medium. In this way, it comes as the ratio of the speed of light in vacuum to the speed of light in the medium. Now, just a minute. This is okay. So here what happens? See, we come to know that the absolute refractive index of medium is speed of light in the vacuum divided by speed of light in the medium. So from this what we conclude? We conclude that see this Nm, that is the absolute refractive index of a medium, it is always greater than 1. Why always greater than 1? Because it is the ratio of speed of light in vacuum to the speed of light in the medium, and light travels fastest in the vacuum. Light travels fastest in the vacuum. That's why this ratio will always be greater than 1. Okay, then sometimes what happens, a question will be given to you that the refractive index of this glass is 1.5. Glass is 1.5. What does it mean? What does it mean? Okay, now read that. Okay, the refractive index of glass is 1.5. It means that, okay, the ratio of the speed of light in vacuum to the speed of light in glass is 1.5, or you can say that the speed of light in vacuum is equal to 1.5 times the speed of light in glass. Okay, or you can say that the speed of light in glass is 1 upon 1.5 times the speed of light in vacuum. आप इन तीनों में से कोई भी आंसर लिख सकते हो, but okay, prefer to write the first one or second one. Okay, what happens over here? The refractive index of glass is 1.5. It means that the speed of light. Okay, then okay, the speed of light in the vacuum is 1.5 times the speed of light in the glass. Or the refractive index of the glass is 1.5. It means that the ratio of the speed of light in vacuum to the speed of light in glass is 1.5. Okay, then next. After that, what comes over here is about the absolute refractive index. Okay, now see here. Okay, see, if you solve again further, you will get one more formula for the refractive index. Okay, and you see here. Yes, here. See, you got that N21 is equal to V1 upon V2. Okay, given equation 1. Just now we got that this N1 is equal to C upon V1 given equation 2, and N2 is equal to C upon V2 given equation 3. Now divide the equation V2 divided by C upon V1, and when you solve it, it will come how much? V1 upon V2. V1 upon V2, equation 4. Look at this. What is V1 upon V2? V1 upon V2 is equal to N21. So you got N2 upon N1 is equal to then N21. Okay, now see. Okay, you got one more formula for the as a refractive index of the second medium with respect to first medium. Okay, done. और तो general में से over got it. So in this way what happens, see, practically when you will go to solve the paper, question paper, then you have to use only two formulas for the refractive index. Okay, other formulas are not useful, and those formulas are like this. This refractive index of second medium with respect to first medium is equal to V1 upon V2 is equal to N2 upon N1, and then one formula N1 or N C upon V1. Okay, only this much you have to use while solving the numerical. Other formulas are not applicable while solving the numericals. Okay, तो सब कुछ भी use नहीं होता है. Those play, then just for sake of our knowledge we study them and we do not use them anywhere. Okay, तो this is all about the refraction. Okay, अब यहाँ पे याद रखना कि जो refraction होता है, तो refraction depend upon the wavelength. We saw that formula for the refractive index. Okay, refractive index of a second medium with respect to first medium is lambda 1 upon lambda 2. So what happens? How much bending will take place? Okay, how much bending will take place, that depend upon the lambda, and lambda decides the color of the light. Lambda decides the color of light. So we come to the final conclusion that the different colors of light will bend by different angles when they go from one medium to another medium. So what happens over here naturally? Now see what will happen. We got another important answer from this, that how the dispersion of light takes place. Suppose this is the surface, the white light is coming and striking over here. Then, so when the light travels in a straight line, all 7 colors travel together. But when it enters in the medium, okay, what happens? Different colors bend by different angles. The red will go over here, the orange will go next, and then next, and then next, and next. In this way, what happens? The one which will have the highest, largest wavelength will bend the least, and the one which has the smallest wavelength will bend the most. And in this way, what will happen? The bending will take place. In this way, the bending will take place. Okay. Then next, after this comes refraction through the glass slab, rectangular glass slab. Okay. So if you take a rectangular glass slab, then a rectangular glass slab, okay, then it creates two interface, okay, at the two parallel edges. One above where the light will go from the air to glass, okay, and one below where the light will go from glass to air. Okay, then suppose here this is the normal, then the ray of light is coming from the air striking the surface of the glass slab, then it won't go in the straight line. It won't go in the straight line, but it bends and goes in this direction. Okay, after reaching to this point, then once again see, as the medium is changing, the light is going from glass to air, then the direction will change, and this time it will go in this direction. Okay, so angle of incidence, angle of refraction, angle of emergence. Okay, and the distance between the two rays is called as the lateral displacement. It is called as the lateral displacement. Lateral displacement. Okay, then how will you define lateral displacement? Then lateral displacement is the perpendicular distance between the extended incident ray and the emergent ray. The perpendicular distance between the extended emergent ray and the extended incident ray and the emergent ray is called as the lateral displacement. Okay, here also you will observe one important fact, that this here angle of incidence is equal to angle of emergence, and they both are greater than angle of refraction. Angle of incidence is greater than, equals to angle of emergence, and they both are greater than angle of refraction. Okay, this you have to remember. Okay, then next. Now, here what happens? We have to prove that the emergent ray is parallel to the incident ray. The emergent ray is parallel to the incident ray. So, how will you prove that the emergent ray is parallel to the incident ray? Okay, it's very simple. See, what happens over here? Then, here the light is bending twice. The light is bending twice. So, here what happens? Suppose this is one refracting surface, this is another refracting surface. Then at the first refracting surface, the ray of light is coming, striking over here. It is bending in this direction. Okay, it is bending in this direction. It was supposed to go over here, but bending away from the normal. Then after that, what happens at this point? It bends in the opposite direction. So if you draw two lines over here, you will find that. See, these two angles are exterior. What do you call vertical angles? No, not vertical opposite angle. Which angles are they? Exterior alternate angles. They are equal. Exterior alternate angles. They are equal. That's what will happen. The two rays must be parallel to each other. In this way, we can prove that the incident ray is parallel to the emergent. Okay. Then, and here what happens? The lateral displacement which is produced over here, it also depends upon two factors over here. See, actually depends upon four factors, but we'll study only two factors because here what happens? See, the first factor is the color of the light, but in our practical life we are using only the white light. That's why what will happen? That color won't make any effect over here. Okay, so the first factor which will affect the lateral displacement is thickness of the glass slab. It is the thickness of the glass slab. Suppose the ray of light is coming over here, it's making this at an angle of 45 degree. Then after that it will bend and go in this direction. Then over here once again it will bend and come out at 45 degree. If you extend the two rays, then you will find that this is the lateral displacement. Now keep the same angle of incidence over here, that is 45 degree. Then the light will bend by the same amount. It will go over here and then come out at the same angle of 45 degree. Then extend this. Then you will find that the lateral displacement has increased. See, as the thickness of the glass slab increases, as this thickness will increase, the lateral displacement will also increase. Okay, then next thing. Second time what happens? Here what happens? We keep both the angle of incidence 45 degree. Okay, we keep both the angle of incidence 45 degree. Okay, next time we'll change the angle of incidence. Okay, we'll change the angle of incidence. Now let us see what happens when we change the angle of incidence. So when you change the angle of incidence, keeping the glass slab of same thickness, means what happens? You took the two glass slab over here which are having the same thickness. Okay, now see, suppose in the beginning the angle of incidence was very small, so angle of refraction will also be very small and the ray of light will come out from here and then extend this. Okay, this is the lateral displacement. Okay, then suppose this is the angle of incidence. Now it has been increased by a large value, so it will go here, then it will come out from here. Then okay, see, as the angle of incidence increases, the lateral displacement also increases. In this way, we can prove that the lateral displacement depends upon the two factors: angle of incidence and the thickness of the glass slab. But remember, when you talk of the angle of incidence, that time the thickness is same. When you talk of the thickness, that time the angle of incidence is same. And here the two factors are not discussed. The first one is color of the light, because this bending will be different for the different colors. So the lateral displacement will also be different for the different colors. But here what happens? We are using the white light. We are using the white light. That's why we will not use the this color. We won't talk about the color. And second thing, it also depends upon the refractive index of the glass. Because if you go in the market, you will find that there are different types of glasses. There are different types of glasses, and because of that, what will happen? All the different glasses will have different refractive index, and then bending will be different, and hence the lateral displacement will also be different for the different medium. But here, what happens? We are using the same glass everywhere. That's why we will not consider that factor also. Okay. Then next, after this comes this. This is about the refraction. Then come the lenses. Okay, lenses and then mirrors. Okay, so we saw the mirror many a times. Let us see the lenses. Okay, image formation by the lenses. Hope you all remember how to form the images using the lenses. Okay, then by the time all will share the result on WhatsApp. Yes, all of you share your result.
Just a minute.
Priyanshu, Arjun.